Voyager 1. Voyager 1 is a space probe launched by NASA in 1977 to study the outer solar system and beyond. It has traveled farther from Earth than any other human-made object and is currently the most distant man-made object from Earth at more than 14 billion miles away. Among its many achievements, Voyager 1 conducted flybys of Jupiter and Saturn and discovered several of their moons.
It also captured the iconic pale blue dot image of Earth from a distance of 3.7 billion miles. In 2012, it became the first spacecraft to enter interstellar space, marking a significant milestone in human exploration of the cosmos. Despite being over 40 years old, Voyager 1 continues to communicate with Earth and provide valuable scientific data.
Voyager 1 is currently zipping through space at around 38,000 miles per hour, which is 17 kilometers per second. At a distance of 23.844 billion kilometers from Earth, it is the most distant human-made object from Earth. The Voyager Imaging Science Subsystem is a modified version of the slow-scan Vidicon camera designs that were used in the earlier Mariner flights.
The system consists of two cameras, a high-resolution narrow-angle camera and a lower-resolution, more sensitive wide-angle camera. Unlike the other onboard instruments, operation of the cameras is not autonomous, but is controlled by an imaging parameter table residing in one of the spacecraft computers, the Flight Data Subsystem. The probe made flybys of Jupiter, Saturn, and Saturn's largest moon, Titan.
NASA had a choice of either doing a Pluto or Titan flyby. Exploration of the moon took priority because it was known to have a substantial atmosphere. Voyager 1 studied the weather, magnetic fields, and rings of the two gas giants and was the first probe to provide detailed images of their moons.
In the 1960s, a grand tour to study the outer planets was proposed, which prompted NASA to begin work on a mission in the early 1970s. Information gathered by the Pioneer 10 spacecraft helped Voyager's engineers design Voyager to cope more effectively with the intense radiation environment around Jupiter. However, shortly before launch, strips of kitchen-grade aluminum foil were applied to certain cabling to further enhance radiation shielding.
Golden record. Each Voyager space probe carries a gold-plated audio-visual disc, should the spacecraft ever be found by intelligent life forms from other planetary systems. The disc carries photos of the Earth and its life forms, a range of scientific information, spoken greetings from people such as the Secretary General of the United Nations and the President of the United States, and a medley.
Sounds of Earth that includes the sounds of whales, a baby crying, waves breaking on a shore, and a collection of music including works by Wolfgang Amadeus Mozart, Blind Willie Johnson, Chuck Berry, and Valia Balkanska. Other Eastern and Western classics are included, as well as various performances of indigenous music from around the world. The record also contains greetings in 55 different languages.
Initially, Voyager 1 was planned as Mariner 11 of the Mariner program. Due to budget cuts, the mission was scaled back to be a flyby of Jupiter and Saturn and renamed the Mariner Jupiter-Saturn probes. As the program progressed, the name was later changed to Voyager, since the probe designs began to differ greatly from previous Mariner missions.
Voyager 1 was constructed by the Jet Propulsion Laboratory. It has 16 hydrazine thrusters, 3-axis stabilization gyroscopes, and referencing instruments to keep the probe's radio antenna pointed toward Earth. Collectively, these instruments are part of the attitude and articulation control subsystem, along with redundant units of most instruments and 8 backup thrusters.
The spacecraft also included 11 scientific instruments to study celestial objects such as planets as it travels through space. The radio communication system of Voyager 1 was designed to be used up to and beyond the limits of the solar system. The communication system includes a 3.7-meter diameter high-gain Cassegrain antenna to send and receive radio waves via the 3 deep space network stations on the Earth.
The craft normally transmits data to Earth over Deep Space Network Channel 18, using a frequency of either 2.3 GHz or 8.4 GHz, while signals from Earth to Voyager are transmitted at 2.1 GHz.
The Grand Tour. The Voyager missions took advantage of a special alignment of the outer planets that happens just once every 176 years. This alignment allows spacecraft to gravitationally slingshot from one planet to the next, making the most efficient use of their limited fuel.
NASA originally planned to send 2 spacecraft past Jupiter, Saturn and Pluto, and 2 other probes past Jupiter, Uranus and Neptune. Budgetary reasons forced the agency to scale back its plans, but NASA still got a lot out of the 2 Voyagers it launched. Voyager 2 flew past Jupiter, Saturn, Uranus, and Neptune, while Voyager 1 focused on Jupiter and Saturn.
Voyager 1 enters interstellar space. Voyager 1 left the heliosphere, the giant bubble of charged particles that the Sun blows around itself, in August 2012, popping free into interstellar space. The discovery was made public in a study published in the journal Science the following year. The results came to light after a powerful solar eruption was recorded by Voyager 1's plasma wave instrument between April 9th and May 22nd, 2013.
The eruption caused electrons near Voyager 1 to vibrate. From the oscillations, researchers discovered that Voyager 1's surroundings had a higher density than what is found just inside the heliosphere. Since flying into interstellar space, Voyager 1 has sent back a variety of valuable information about conditions in this zone of the universe.
Its discoveries include showing that cosmic radiation out there is very intense, and demonstrating how charged particles from the Sun interact with those emitted by other stars. The spacecraft's capabilities continue to astound engineers. In December 2017, for example, NASA announced that Voyager 1 successfully used its backup thrusters to orient itself to talk with Earth.
The trajectory correction maneuver thrusters hadn't been used since November 1980, during Voyager 1's flyby of Saturn. Since then, the spacecraft had primarily used its standard attitude control thrusters to swing the spacecraft in the right orientation to communicate with Earth.
Remaining lifespan. In December 2017, NASA successfully fired up all 4 of Voyager 1's trajectory correction maneuver thrusters for the first time since 1980. The TCM thrusters will be used in the place of a degraded set of jets which were used to help keep the probe's antenna pointed towards the Earth.
Use of the TCM thrusters will allow Voyager 1 to continue to transmit data to NASA for 2 to 3 more years. Due to the diminishing electrical power available, the Voyager team has had to prioritize which instruments to keep on and which to turn off. Heaters and other spacecraft systems have been turned off one by one as part of power management.
The fields and particles instruments that are the most likely to send back key data about the heliosphere and interstellar space have been prioritized to keep operating. Engineers expect the spacecraft to continue operating at least one science instrument until around 2025.
In conclusion, Voyager 1 has been one of humanity's greatest space exploration achievements, providing us with a wealth of scientific knowledge about our solar system and beyond. Its continued journey beyond our solar system serves as a symbol of human curiosity and our unrelenting desire to explore and discover the mysteries of the universe.
The mission of Voyager 1 has truly expanded our understanding of our place in the cosmos and will continue to inspire future generations of scientists and explorers.